All right, amazing students, we're back with the rest of 1.4. I decided to go ahead and post it in two pieces so that it would load a little faster. So we are starting number 50, and number 50 is another one where we're supposed to find a parallel line and then a perpendicular line. But if you notice that our given line is just a y line, and a y line is going to be horizontal, right? So since this is horizontal already, we know that the slope is 0. So the slope is 0, and we want a vertical line to be its perpendicular, and the slope would be undefined. Okay, so because of that, and because we know it's a y line and an x line, this one is going to be y equals something, and this one is going to be x equals something. All we have to do is look at our point. So we're going to get the y value, -5, and the equation of the line that is parallel to this line through this point is y is -5. And for the x line, which is the perpendicular line, the vertical line, we're just going to choose the x coordinate 4. And we are done. We found the two lines and we're finished. Okay, so this one is number 60, and all we were supposed to do with number 60 was determine whether it could be approximated by a linear function, and that's a definite no. This one looks more cubic than anything else, so I just went ahead and put a no there. We did one just like that. So if it doesn't look kind of close to a line, it's not going to be able to be approximated by a line. But this is where we're going to spend the rest of our time on this video. Actually, two problems that are one problem. We're going to do 61 and 67. 61 is the manual calculations. We're going to model this data with a linear function manually, meaning we're not going to use the graphing calculator. And then we're going to use this line that we create to predict two future costs in 2018 and 2023. Now notice when they present the data, they've got each year here, but as they go down, they're saying year 2009 is 0 year. Year 2010 is 1 year. So all we have to do to find the year, which is going to be our x value, is we're going to take whatever year it is, take away 2009, and we will get the year. So as we're looking at this, 2018, when we take away 2009, that's going to be the 9th year. Okay, and 2023, when we take away 2009, is going to be the 14th year. Okay, so we're going to be doing year 9 and year 14 when we get that part of the calculation. So this is problem 61 in your textbook, so you can look straight out of there. And the first thing I'm going to do is try to find a slope for this data. Now I have not seen a graph of that data, but in looking in the book, they didn't really want you to see a graph of the data right now. We can surmise that it's probably somewhat linear because of what? As we increase, what's happening here? It's going a little bit up each time, okay? And okay, so here was a jump that was a jump of 40. This was a jump of 11. This was a jump of 16, a jump of 20, a jump of 22. So definitely not linear, but maybe something that could be approximated by a linear function. Okay, so in order to do that, I'm just going to, out of the clear blue, since I don't know how these are going to graph out, I'm going to just choose this first point, and I'm going to choose this last point as my 2 points that I'm going to use. Now, in the book, they even say that you can get different answers for this because it all depends on which ones of your slopes, my daughter's trying to sneak by here, which one of your points you choose to figure out which one is your slope. So we're going to use those 2 points. So right here, I'm going to use 0 and 293 and 5 and 402. We're going to use those 2 points. Okay, so I went ahead and put the 2 points that we're going to consider up on the top of the board, and I went ahead and figured out the slope. The difference in the y's divided by the difference in the x's is going to be 21.8. So we're going to go with this slope, and so we're going to take y equals mx plus b. I'll do this one with slope-intercept form. And so I'm going to put in my slope, which is going to be 21.8. I'm going to put in my x from this point. I think this point looks a little easier than that one, so we'll put in our x from this point, which is going to be 0. Our x is 0. Okay, and then we're going to put in our y, which is 293. All right, so now we're going to calculate out our b, and of course this one's going to go to 0, so we're going to get b is equal to 293, which is what we should have gotten because this is just a y-intercept. Okay, so where our equation is going to be y is m 21.8 x plus the b, which was the y-intercept, 293. Now that's what we get when we just, so that's what we get for our equation of the line, which again would change depending on which of the points we took. But taking this equation, we are, if we're now looking back at our little instruction page here, we just did A, okay? And we got y equals 21.8 x plus 293. Okay, so we just did the first part there. So now we're going to plug in the values for the 9th year and the 14th year. Okay, so back to our calculation page here. So the 9th year is meaning we're going to plug in 9 for x and see what comes out for y. So for the 9th year, we have y equals 21.8 times 9 plus 293. Okay, and then for our 14th year, which I'm going to go ahead and write here because I'm going to have to go to the calculator for both of these, we're going to get y is 21.8 times 14 plus 293. Okay, so I'm going to put the board down so I can get my calculator up, and I'm going to calculate those for us real quickly. 21.8 times 9 plus 293. Okay, so I get 489.2 for the first one, 489.2 for the 9th year. Okay, hopefully you're doing this at home on your board as well, or your paper. And then I'm going to do the 14th year, which is 21.8, which was the slope, times 14, which is the year we chose, and then plus 293, and that's going to give us 598.2. Okay, which makes sense. All of our data was increasing, wasn't it? As it went up, it was increasing. And so this is the 9th year and the 14th year. And so those make pretty good sense. Okay, so we have finished problem 61, which was to do all of this by hand. And now we're going to do the same thing, but we're going to use Linreg. Okay, so we're on problem number 67 now. And 67 tells us to use our graphing calculator and find the Linreg Okay, and then we're going to predict 2018, which was one we already did before. It was our 9th year here. And then we're going to compare with what we got before, and we're going to find out what our correlation and coefficient is in our calculator, because our correlation coefficient gives us an idea of what kind of how good a match we have for a line. So when we're going to start, I have a nice clean calculator here. Okay, as we're going to look at the calculator, we're going to say, all right, I am going to go to Stat, and see if you can see my screen here. I'm going to go to Edit. So Edit is the one that's already highlighted. So I'm going to stay right there, and I'm going to enter. Okay, so just hit the little enter button down here when you get to Stat Edit, and it takes you to your list of points. Okay, which I have only got to clear out the first point. So I'm going to clear and enter. So basically I have a nice clean slate. If you don't have a clean slate, move your cursor up to L1 and press clear and enter, and then move it over to L2 and press clear and enter. Okay, so now I'm going to start entering these points, and my first point was 0 to 93. So 0, I'm going to enter all of my x's first because it's just faster. Okay, so I'm going to enter my x's, 0 and 1 and 2 and 3 and 4 and 5. Okay, so 0, 1, 2, 3, 4, 5. Looks like I did that correctly. Can everybody see? Okay, and then I'm going to enter the values in the L2 column. So I'm going to cursor over here to my L2 column, and I'm going to put in 293, 333, 344, 360, 380, and 402. Okay, if I did it right, and I think I did, my points are matching. Okay, 364. All right, so my points are matching each other. In other words, I have the same number of points. If you ever try to graph something and you don't have the same number of points in both columns, it will give you a mismatch error. Okay, so it looks like I'm ready to graph those. So I could graph, okay, and it's going to give me the value. Let me look in my, see, it's graphing what I have in my Y line. You have to make sure you clear that out before you go. So now I'm going to graph, and I see nothing. Why do you think I see nothing? Because I graphed my points, but remember, my points don't start until 293. So I have some window adjustment to do here so that I can even see what I'm doing. So I'm going to adjust my window, and I'm going to make my leftmost x be 0, and I'm going to make my rightmost x be 5. Okay, so I'm just going to narrow it down to where I just see my points. Okay, I'm going to let my scale be 1. Okay, and then my Y min is going to be 290. I'm just going to put 290 so I'll actually see the point here. And then I'm going to put my Y max is going to be 405 because my highest point is 402. And then I'm going to have my Y scale, because that's a pretty good distance. I'm going to have my Y scale. I'm going to move it to 10 instead of 1 and see how many of my points I can see now. Okay, so now I'm going to graph again and see what I can see. All right, so okay, so the first time I did it, I had nothing. And the reason I didn't have anything after I changed my window is because I had turned my stat plot off for some reason. So now I have my data. So if you ever, you're looking, you should have points. If you go to second and stat plot up here, second stat plot, then you can find out what you have turned on and what you have turned off on your screen. And I had all of them off, which means I'm not going to see anything in the way of points. Okay, but I turned the first one on, which is your default, and it should be on. So now when I graph it, I can see all 5 of my points. All right, I actually have 6 points, but I'm only seeing 5 of them because I'm thinking, let me see, 1, 2, 3, 4, 5. Oh, the other point is right down here because I had made it 0. So I should probably change my window to -1 for the first x. And I changed my x max to 6. So I'm going to go 1 on each side. And now I can actually see that there's a point there, but it's right on the axis, and it's just a little darker blip down there. So I have all 6 points that I can see, and I'm hoping you can see on my screen. Okay, so now we've got our points plotted, and as we look at our plot points, now that we can see, it does look pretty linear in its representation there. Okay, so now what we're going to do is we're going to go find the equation using Linreg. So we're going to go to Stat, and we're going to go to, over here at the top, you can see, let me see if you can see, the Calc up there, okay? So we're going to cursor over to Calc. Now that Calc is highlighted, we're going to hit Enter, okay? And we're not going to do that because we went to one variable stats. We don't want that. So we're going to go back to Stat, Calc, and we're going to go down to number 4 is what we want to do. We're going to go down to Linreg. Okay, so I am now on Linreg, and notice it says AX plus B. Okay, that's what I'm looking for because I'm looking for it to come out in a line. So I'm going to hit Enter, and mine defaults to L1 and L2. Some calculators you have to type in L1 and L2, but mine is going to default. So if I'm using L1 and L2 as my 2 lines of data, then I'm just going to hit Enter again. And when I hit Enter again, I get this nice screen that gives me the form of the line, y is mx plus b, except they're using ax plus b because their variables are labeled a and b. Okay, so we're just going to take the a and plug it into the line where the a is, and the b and plug it into the line where the b is. Now down below, we have our correlation coefficient. And notice down here, it's called the R, okay? Now your R squared, we're not dealing with right now. We're just looking at R. And R squared is 0.98. And R is never going to get bigger than 1. R will always be between +1 and -1. It is your indication of how good your line is in representing your data points. And 0.98 is really, really close to 1. So we would say this one has an excellent correlation coefficient. It is not exactly a line, but it's pretty good. Okay? So when we're putting our line down, we would take our A from our calculator screen, and our A is 20 point, so we're going to say Y is 20.0571x plus, and then my B is 301.86. Okay, so there is my actual line that comes from the Linreg on the calculator. So this is called a best fit or least squares regression. And it gives you, if you were a data analyst, you would want to use this line over a line that you created using the points. Because what this Linreg does is it takes the distance between each one of the points to the line and minimizes that distance. So it is the best fit for your data. So now what we're going to do is we're going to go over here and see the cool line going through our data. So I'm going to take this line that I've put down on my board, and I'm going to go to my y equals here. And my y equals is nice and clean. And I'm going to put in that line. So I'm going to enter in 20.0571x plus 301.86. And I'm going to enter that. And now I'm going to graph. And now you can see that my line goes right through the center of my data. You see all my data points? And 1, 2, 3, 4 are actually touching the line. And then there's 2 of them that are actually off the line. But it looks like that the data gets more linear as you get farther on, because the 2 points that are off were the first 2 points, and after that they really lined out, didn't they? Okay, so now this is back to 67, and so if we're looking at this line, and now we're going to predict 2018, okay, and the 2018 we're going to plug right here into our X. And of course, I'm going to do that with the calculator. But remember, 2018 take away 2009 was year 9. Okay, so we're going to plug in not 2018, but 9 right there. Okay, so here we go with the calculator. I'm going to say 20.0571 times 9, enter, plus 301.86, and I'm going to get 482.37. Okay, so 482.37 is what we came up with when we did our Linreg, and when we had done the same year using our formula, we got 489.2. Not a lot of difference. Okay, 7 points difference, not too bad for a future prediction, but that's not future anymore, is it? It was future when the text was written and when the problem was done. But that is not bad, but those first 2 points were the ones that were the most off on the line and the points. So I used that first point as one of my points to find the slope. So because that point was off, I didn't get as good a slope. So always use the Linreg when you can. And of course, the third part was the correlation coefficient, which is the R on your screen. And once you get that R, ours was 0.98, which is very, very close to 1. So this was a great correlation. Our data was very nicely fit to that line. And that is the end of 1.4, and we've had some good calculator work. And so I'm going to come back in a little bit with 1.5. I'm trying to get this all done so that you can have it for your test. And this is Mrs. A, and may God bless your day.